Hey guys, I have another problem for you guys about percent yields and a couple things that I want to share regarding just like real life, how you will be using these percent yields in lab in the spring. I know that it probably won't pertain to you as much in the fall, but I'm sure you will have a question like this on a quiz or an exam. So it doesn't hurt to um, talk about it now. So percent yield, we just want to know the formula real quick, is your actual divided by your theoretical times 100. And I like to write it out as your actual is your experimental. So that's what you did that's what yielded. That's what you got whenever you, like let's say you recrystallized or um, you reacted. That's what your actual is. And your calculated is going to be what you got whenever it gave you your initial amount. So let's say you started off with, if you started off with 35 grams of bromine, that's what's going to be, and whatever you yield whenever you do the calculation, that's your theoretical. And I think that's really important to note because whenever you get to lab, I know students will actually get confused on which is which. So, yeah, it's a good thing to keep in mind. Another thing is percent yield greater than 100%. So if you get a percent yield that's greater than 100%, you might think that at that point, you'd probably think that you did something wrong. Not wrong, but I would say that you most definitely don't have a pure product. And the reason why I say that is because if you have a percent yield of greater than 100%, that means that you have either a contamination. Let's say you dropped your product on the lab table and you swept it up and you measured it and you accidentally swept up some product that was already there. So, that could be a contamination there. Another thing is impurities, and that has to go with side reactions. So, sometimes when you react things, it's not, and you'll learn this later on in the semester, sometimes when you react things, it's not going to completely react, or other reactions can form from that reaction. That can cause a different weight to have occurred in your product. And in that case, all you would have to do is really, it needs purification. You can rinse it with ethanol, or you can do a distillation process. There's a lot of different purification methods out there, and you'll learn more in Orgo Lab. But yeah, and I would say, like, probably the most common thing is it's not going to be dry. Sometimes you'll use a vacuum filtration setup to dry your product. And when you measure it, it's not completely dry. I would, in that case, your water is adding weight to your product, and that's going to cause your percent yield to be greater. But I guess a little tip that I'm trying to point at is if you get a percent yield higher than 100%, you know that you need to go back and double check your work, or you need to write down, like in your lab report, why you had a percent yield greater than 100%. And then one of these couple reasons will probably be why. But without further ado, let's get right into the problem. A couple students were telling me that they were having problems actually writing out the equation just from the words, so let's go ahead and do that. So phosphorus reacts with bromine. We know bromine is a diatomic molecule, so it's going to be Br2, just like iodine would be I2. Hydrogen, H2, oxygen, O2. You need to memorize those. To form phosphorus, tribromide. Now we need to balance it, because I know right off the bat it's not balanced. You can use the tally up method that I spoke about in my last video, or if you're good and you've practiced that, and these have come simple to you, then you should be able to just do them in your head. A simple one like this one at least. So the problem says that 35 grams. Right off the bat, we know we have 3 sig figs. 35 grams of bromine reacted, and this was produced, so this is your actual. You don't need to do any calculations with this. So we have 35 grams of bromine. We're going to use our mole to mole ratio. 1 mole of bromine is equal to 159. I believe. Let me double check that real quick. Yeah, 159,808 grams. We have 3 moles of bromine, so for every 3 moles of bromine, we have 2 moles of phosphorus tribromide. And we want to get mass, so we're going to do 1 mole of phosphorus tribromide is equal to 270.686 grams. And really you can do 2 sig figs on that just to be extra sure. I just added a third one. And that's going to yield 39.5 grams of phosphorus tribromide. In real life, that's what your experiment should have yielded. However, that's most likely not the case. I think you're going to lose some product. And I want to write that down so you guys know. You're always going to lose some product. And sorry, that was my timer to tell me that I have office hours in 15 minutes. You're always going to lose some product. And you're going to lose it just by transferring. Like if you're transferring from a beaker to a test tube or anything really, you're going to lose product on the sidewalls. It's going to happen, or you're not going to like pick it up all the way, or it's going to get dissolved, or it's just going to happen. So realistically, you really won't get the 39.5, or you'll get pretty close. You could get like 38. I mean, I'm not to say that you're not ever going to get the actual yield amount, but it most likely isn't going to happen. You're going to lose some product. So now let's actually do the percent yield. We had our actual, which was 27.9 grams, divided by our theoretical, 39.5 grams. We want to multiply that by 100. We get 70.63%. We're at 3 sig figs, so that's our significant digit, so it'd be 70.6%. But yeah, that was our problem. It was pretty quick and straightforward. I just wanted to really mention the percent yields above a grade 100% and how these would be applied in the actual lab. If you guys have any more questions, feel free to email me. Keep up the good work, guys. I'll see you on my office hours. Go Frogs!